Hello everyone, in this video I would like to demonstrate how can we implement this function CIP Client, or we call it Ethernet IP CIP Client function in the Siemens S7-1200 controller. This is the recent application released from Siemens that is really a breakthrough application that allows the Siemens controller 1500 or 1200 controller can implement the Ethernet IP CIP client function. This allows the Siemens controller can directly communicate with the local ControlLogix, CompactLogix, or the MicroLogix. So the CIP communication protocol is full name Common Industry Protocol. Basically, the Ethernet IP has two kinds of communication. One is the message, usually we call it explicit messaging communication way. Another way is implicit method. Basically, when we use the CompactLogix or the ControlLogix to communicate with a remote device, we are using the implicit Ethernet IP communication. But when we try to set up the communication between the controller and controller, when we use the MSG command inside the Rockwell Allen Bradley controller, that is the explicit messaging communication. So going back to this application, the CIP client we are talking about here, that is talking about the controller between the controller. That is an explicit CIP communication. This is really a breakthrough. In the past, we have to use the Modbus TCP or the TCP, set up the communication between the Siemens and Allen Bradley. Or we use the additional bridge, for example, one side that is an Ethernet IP I/O adapter, another side that is a Perfinite I/O device running as a coupler to exchange the data between the two systems. So that's really annoying, but this application allows them to communicate directly. So let's scroll down, and from this application, it has a version 13 and TIA Portal version 15, two versions here. In this case, I will use this version 16, and highly recommend you need to download this PDF file and read the detail. Also, I would like to mention for the CIP server function, you can click this link, and here it has a CIP server function. Siemens also released the Ethernet IP scanner function. I will use other videos to show this application demonstration. And comparing with the CIP server and this CIP client, I would recommend we use this CIP client. That allows we only need to program the Siemens side, and Allen Bradley side, we do not need to touch anything. If we use this CIP server function, that means Siemens side will run as a server. You need to go to the Studio or RSLogix 5000 to set the data mapping for the CompactLogix, or you need to program the MSG message program in the MicroLogix. I would recommend you use this CIP client, so we only need to focus on one side. Alright, let's shift to the TIA Portal side and let's implement this example project. Alright, after we download this application, take care of this ID number, so you can find this ID number from Siemens application example. Okay, current version, that is version 1. Let's unzip. Let's open the TIA Portal version 16. This project, that is a version 16 compressed project here. Okay, let's go back to the TIA Portal version 16. And then let's shift to this project wheel. Go to project. Okay, let's open this application. And then the system will ask, let's retrieve one folder directory. Okay, we'll retrieve this project. All right, inside this example project, it has a 1215 controller and 1511, this two series controller example. Personally, I would recommend we can change this adapter and this scanner to client, because when we talk about the explicit messaging function, we are talking about the server and the client function. That's why this project is named CIP Client. So this adapter and the scanner will cause a little bit confused. And in this test, I will set up the CIP Ethernet IP communication between the Siemens 1214 and CompactLogix controller. So I will copy this project. I will change the CPU configuration based on my actual hardware. Okay, I will copy and paste. And one fortunate thing is that the function block for the 1200 and the 1500, they all compatible. So once we test successfully for this 1200, that also means 1500 shouldn't have any problem. Okay, So here, let's rename this project. Okay, I will name it CIP Client function. Okay, and I will use this project. Let's open. And firstly, I will change the hardware configuration, replace, change device, and I'm using 1214 DC DC DC. This is my controller. This is the controller from example. Okay, I'm gonna replace this controller. Okay, this is a 1214. Okay, it changed successfully. And now let's click this Ethernet port here. I will configure the Ethernet IP configuration. Go to the Ethernet addresses. Okay, here I will change the IP address. And in my case, the Siemens controller its IP address is 192.168.1.181. And Alan Bradley IP address will be 1.191. Okay, and this subnet, let's change it. Okay, this is the common subnet setting here. Okay, so we only need to change the IP address associated with your actual case. And let's see this example, OB1. So the project is pretty simple. It has IP1 is a sealed function block, and it has an instant DB. Also, this is a raw call tag. This is the actual communication tag. This is the example structure here. This area is used to set this server IP because now the raw call Alan Bradley is running as a server, and the Siemens 1200 controller is running as a client. So the client need to know where is the controller, where is the server, right? So here we need to set the IP address. This IP address is an Alan Bradley IP address. So I will name it. In this case, I'm using Alan Bradley CompactLogix L32E, and its IP address is 1.191. Okay, here I will change this IP address. Tell this client to find this server, 191. This is the Alan Bradley IP address. Okay, and at here, keep in mind, by default, this enable is set the false from this example. I highly recommend that you can connect one tag here. Also, from this watch list, we can set this enable signal here. That comes from the instant enable. Okay, don't forget, in the actual case, you need to connect one tag to control the enable or disable this communication. And keep in mind this perfect net interface. The 64, where this come from? So if we back to this device configuration, click this Ethernet port, and you will see this system constants. Here, for this Ethernet port, its hardware ID is a 64. So go back to this program here, that is a 64. All right, and server IP. The server IP come from, this is a OB1. This is a local temp variable, and from the top line, top network here, we set this IP address. Basically, those IP address number set to this local variable, and this local variable set to this function block interface, input interface. And regarding this slot number, by default, it's set in 0. Its number can be 0 to 15. To read the detail for this slot number, I highly recommend go back to this application example from this ID, and you read the detail from this PDF file. So if we go to the appendix here, for the CIP communication, especially if we scroll down, here it shows some example. For example, sometimes the processor module is at the slot of number 5. So the slot number we need to set. Keep in mind this number. Basically, for the CompactLogix, its Ethernet port comes from its built-in Ethernet port from the CPU processor. So the slot is a 0. Okay? And this raw call tag, my tag, this is one important tag structure. Let's go to the DB1. This is that DB. This is very important. By default, this example leaves you 3 data here. We can expand this data. For example, I can expand to 5, leave 6 buffer here. Each line that represent one tag. That tag need to be communicated. And for the ControlLogix and CompactLogix, because their tag are based on the tag name. So that's why the tag name here, we can directly type in the tag name. And other than the tag name, we also need to know the data type. For example, the tag would be Boolean, integer, or real number, right? From this type code. So Siemens is using this type code to identify which data type they need to communicate with the alarm branch. That data type is a hex number here. For example, if we scroll down, if I zoom in, here the tag type, that is a 00C1. 00C1, that means it's a data sent from the Siemens side to the alarm branch side. So that is the true. That allows this tag write to the alarm branch side. If this tag is reading the data from the alarm branch side to the Siemens side, we need to set it off, false. Okay? And here, this is the actual value we need to monitor. Okay? So now, let's go to the alarm branch side. Currently, I'm using RS-Logix 5000. So the controller what I'm using, that is a CompactLogix L32, this controller, and its version is 20. Basically, all the CompactLogix and the ControlLogix above or equal to 20, this version, they have a similar idea. Okay? In this controller, I set up the variable start remote, stop remote. This is a test bit. Also, I set up one integer and one real variable. So this integer named I. I means integer, data remote. And this real data remote. Okay, now I'm setting 120 and 314. Set an initial value at here. And I will use the 1200 PLC send this remote start and remote stop, control these two boolean. Also, I will feedback send from the CompactLogix back to the 1200 PLC, send back these two variables. One is an integer, one is a real. And keep in mind, all those variables, those four variables, if I click this edit, all those variables come from this controller tags. If we double click, we will see the start remote, stop remote, real data remote, and integer data remote. They all controller tags. So the variable under this controller tags, they are quite straightforward. One more special, that is a tag under the main. One special, that is a variable under the main program. For example, as we can see, this is local program tags here. So I specially create one local variable named local dent, double integer. This is a local variable. I will specially use this local variable for a test. So basically, this local dent and this start remote, stop remote, data remote, integer, and real, we will communicate between these two systems. Okay, from this ControlLogix wise, those are sample program. We do not need to specially program any communication program. For example, MSG, message communication. We do not need to program that. We just need to declare the variables under the controller tags or the program local tags. All right. So from the Siemens side, we need to declare, we need to register those variable names inside the DB. Okay, let's shift back to TIA Portal. All right. First variable I will write here, and that is a start remote. And this is a Boolean signal. So this tag type, I will write down, that is a 00C1. And we will send the data from the 1200 to CompactLogix. So I will write this tag write. Set this permission, written permission. So I will set true. And the second variable, stop remote. That is the Boolean also. So it's data type, that is C1. Same thing, the tag write permission, we will set true. Okay, and this value, when we set the value, we will set the value at here, the word here. Okay, the next variable, I will read the data, integer data from the CompactLogix to Siemens side. So it named the integer data remote. Okay, and because of this is the integer value, so according to the manual, so I will set 00C3, 00C3. And we are going to read the data from the CompactLogix So here, the tag write, I will leave as a default. That means this is reading the data from the CompactLogix to the Siemens side. Okay. Next data, similar idea, I will cite the real value. And according to that table, the real value we will cite 00C8, 00C8. And this is also the data reading from the CompactLogix to here. So that's why this tag write, I will leave as a false. And this is the four variables come from the controller tags. And we will write another tag. If you recall, another tag that is under the main program local tag. It named the local dent. That's the double integer. Okay, I write the name here. But actually, when we set up the communication, this variable will have a problem here. I will show this after. That because those variables come from the controller tag. That come from directly from the controller. This come from the local variable. The local variable from CompactLogix, it has a directory. For example, for this variable under this main program, this is the local variable that is under the main program rather than the controller tag from this here. This variable from this main program is named local dent. Its full name is this. But from the test purpose, I will intend to leave this name here, so we will see if the system cannot communicate correctly, what will be shown here. Okay, and date type, this is the dent. We will leave 00C4, and we will write the data to the CompactLogix side. So I will cite true. Okay, so basically this 2 bit, we will send the data, and this 2 data, integer and real, we will read the data from CompactLogix. And this data, we are going to send the data from the Siemens side to CompactLogix. We are exchanging the data between the two systems. Okay, after this, let's go back to the main one. And from this example, its output here, that is the default, without any output variable here. I highly recommend we can create one DataDB and we can receive all those info here. In case the communication got something wrong, we can diagnose the status. Okay, so here at the new block, and keep in mind this diagnostic, that is a structure. If we double click this function block, it has a password. But once we double click, we can see the actual tag or the basic structure behind. So this diagnostic here is using this data type. Okay, so based on this, we can copy here, paste here, and we will set up the same structure data type. And this is the DB from DB3. So we drag this variable. So once we go online, we can use this DB to monitor the actual status. Okay, this status, this is a word. Okay, I will change to word. In case our online test has something wrong, so we can go back to the menu and check out the error code. If we go back to the manual PDF file, go to the section 6.1. So here, block status message. So we can check out the status code, feedback, and check out what's going on of the system. All right, let's go back. So here we basically finish all the setting. Let's download this controller. Compile and download. Okay, we set the target inside this program here. The IP target, that is 1.191. That is a CompactLogix IP address. And here, we need to enable this function block. And from this simple program, it prepared for us the watch list here. So we can click this monitor. And at here, we can set this instant DB enable to on to enable this communication. If we float, so we can see here, if I go online, when we set on enable, we will enable this input. Let's enable. Okay, here we see that showing the busy and valid That means this client found this server, the CompactLogix controller. So here the quality shows G. That means this client find this tag from the CompactLogix. Everything shows perfect. Okay, now it's showing the same thing, comparing with this tag list. Okay, and correct status, that is a 7002. If we need to find out the detailed status of the tag, we can go to the raw call tag db1. Okay, click this monitor. And now we can see start remote, stop remote, they show G. Good. So here it shows G means good quality. This is the comments here. And the integer data, real value, we read something already here. And because this is the dword, that is the hex value, we can shift to the float or shift to the integer. Let's check it after. And compare with them, the local dent that comes from the local tag under the main program, it shows bad. So this is the problem. If the tag showing something wrong or this client cannot find the tag name, that will show the bad. Okay. All right. Let's temporarily skip this variable. All right. Let me drag some tags variable here. Okay. To specially set or read the data, I will drag this value lines to here. Value. Okay. This full data here. And this number 2 tag, that's the integer data. So I will shift to this display format into decimal. Okay. And this number 3, index number 3, that's the real value. So I will shift to this display format to float value. Okay, we can see it's reading data correctly, 120 and 3.14. And this two bool signal, since this two bool signal that tag write we permit is writing the data from this controller to CompactLogix, so we can send the data here. Okay, and before I send, let's reorganize this window. All right, as we can see, the right side, that's the unlimber-only CompactLogix side, and this side, this is the 1200 side. So now, if I set this two bool signal to 1 and click this write, and meantime we can watch this change. Okay, I will modify this two value, and we can see now the start remote and stop remote it turn on. If I turn this off, I set 0. Set this start value, set this start remote to off. So we can see, and this two data reading from the CompactLogix. So here I can set something here. For example, I can set 250, and this float value I set 6.28. We can see this 250 and this is 6.28. They are reading correctly. Okay, now if we go to the controller tags here, and from this monitor tag, we can monitor this variable actual value. Start remote is 0, stop remote is 1, right? It's same as this side. And this integer data, this is the 250 and 250 here. And real value 6.28. Okay, this is a controller variable. Okay, now let's go to this program tags. This is a local variable here, and it named the local dent. So if we go back to the Siemens side, and if we go to this DB, now it's showing the bad. It haven't communicated correctly yet. So let's go offline. We need to change something. Here, because of this variable is under the main program local tag. So this local tag under this main program is actual directory is this. Let me copy and paste here. This is the actual directory of this tag. And now let me download. But keep in mind, this is the start value here. We also need to change the actual DB value under this string name. So let me firstly download. And let me open this variable watch list, flow it. And let me drag this tag name for this my tag index 4. Drag to here. So this line is a start value, but the actual tag inside this DB is still the old value. So I need to write this value. So I can double click here and paste that full directory. So this is the full directory, and let me write. Okay, now we are writing the full name. Okay, if I click this DB online. Okay, now this is actual full directory. And now let me disable this communication and enable it again. And in the meantime, let's watch this status. Now I disable and let me enable again. So we can see after I re-enabled, so this tag changed to G, good quality. And this is the dent, double integer. So it's transferring the data from this 1200 controller to the CompactLogix because we permit that is true. Tag right here, this is my tag 4, index 4, this value, drag to here. Okay, and let me shift to the decimal, and this is the dent. If I write 1, 2, 3, 4, 5, 6, right into this double integer, and then let's shift back to the Allen side. So from this Allen side, we can see this local dent now is under this main program. So it received correctly 1, 2, 3, 4, 5, 6. If we change the data, we can see immediately this 1200 will override this value because we are sending the data from the Siemens side to Allen side. Okay, if we change this setting, set, so we can see we send it correctly. So this is the data exchanging between these two systems. Now let me do a test. So currently this client status is showing the 7002. That is correct. It's communicating correctly now. Let me do a test. And now I will disconnect the Ethernet cable from the Allen side. And let's watch this status. And after a couple seconds, so the Allen software shows cannot communicate with the controller because we disconnected the Ethernet cable. And here from the Siemens side, it shows 7003. And in the meantime, all those tag quality, it shows B. That means it is not correct. So basically, we can use this status feedback showing the connection is good or not. Okay, if now I connect that controller, and also after a couple seconds, it's shown transfer to 8401. And 8401 from this menu, it shows cannot set up the server connection. That client cannot find that server. Okay, and let's watch it. And if now I reconnect the cable, recover the communication. Click this go online. Okay, Allen side, this communication recovered. And let's watch this status here. And in the meantime, we can see when the communication got wrong, this busy and valid, they all off. Okay, here, I basically wait 1 minute, but this area still shows fault. That means we need to re-enable this communication to reset up the connection. So the system cannot recover itself. Hopefully, in the next version, Siemens can do something, improve this function, allow the client side can reconnect the server by itself. Or we can program based on this 8401. After we read this code, maybe 2 seconds after, we can re-trigger, re-enable this connection to try itself. And now to demonstrate this, I will manually re-enable this. And now let me re-enable this connection. Okay, once we enable, the arrow is still on. So from this function block here, we can see this status showing 7004, and we can see the status showing 8602 and 7004, and this enable is on. So if I try to disable it again, so something is still working behind. I think the next version Siemens can improve this problem here. Like this case, if the communication cable disconnect, and after a couple seconds, the controller recover the connection, and we can do the logic to re-enable this communication. However, the system cannot recover itself. And from this input here, likely there's no way to restart or reset some internal status here. Likely the status will stuck here. The system cannot recover itself. The only way the system can recover itself now, if I try to stop the controller, the Siemens controller here, and restart this controller again. And let's re-enable after the system restart. Okay, if now I restart, so we can see the system recovered, this connection correct now. But that means for this current version of this function block, we have to restart this controller, or we cycle power the controller. That's not quite good. Hopefully in the next version, Siemens can give us a reset way, basically restart the sequence inside and allow this system reconnect the correct connection. Alright, that is for today. In this video, I showed how can we set up the Siemens and Alan Bradley controller. We will use the Ethernet IP client function at the Siemens S7-1200 PLC. This allows the Siemens controller can directly communicate with the Alan Bradley CompactLogix controller. Alright, that is for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.